Hello everybody, this is my Physics 211 project. It is investigation of angular speed of a Crookes radiometer. This is how inside of a Crookes radiometer looks like usually. There is a lightweight rod attached to the surface, and there are four vanes with each one black side and one shiny side. Black sides absorb the incoming light and shiny sides reflect the incoming light. To understand how a Crookes radiometer turns with the effect of the incoming light, we need to know about the two main forces that are acting upon the vanes. The first force is the thermal creep force, which happens due to the thermal creep effect. The thermal creep effect is an effect that happens in a partial vacuum environment. In a partial vacuum environment, gas molecules move from farther to outer side to increase their kinetic energies by colliding. This applies the thermal creep shear stress on the vanes, and this stress makes vanes rotate. The other force, the drag force, which contracts the motion, is a force that happens due to the gas molecules inside. If there are too many gas molecules inside, the vanes will not turn, since gas drag force will contracts the motion and will become larger than the thermal creep force. In this experiment, we tried to build our own Crookes radiometer by using four small sheets of paper with black paint on one side and aluminum on the other side. We used a lightweight rod. We used as a pencil to do this and a needle to decrease the friction. A glass container we used. A vacuum. First, we used a vacuum cleaner. Then it did not work, so we switched the vacuum pump. A tachometer to measure the rotational speed of the vanes, and light sources with different intensity or power. We used these as our equipment. This was our first setup. It was not optimal. We first used it with a vacuum cleaner, as I mentioned, but it didn't work. So we switched the mechanical vacuum pump, as you can see here. Uh, The aluminum sides were damaged, as you can see, and the vanes were too weak. So we switched this. Also, vacuum chamber is also too big, so we switched this system to more optimal one. This one was the best working for all of three setups. This one has smaller vane size and smaller vacuum chamber. This worked actually, but did not work properly since the aluminum sides were damaged and vanes were misaligned. You can see it a little bit here. I will show you a video about it. So you can see our attempts to make it turn. You can see it vibrating with the incoming light source. And you can see the misalignment of the vanes. It vibrates with the incoming lights. At the end, it will become more clear. You can see it clearly here. It vibrates with the light. You can see it. After the second setup did not properly working, we went for the third setup. This time we made bigger vanes and we made sure to carefully insert the vanes inside of it to not damage aluminum sides, shiny sides. And we used even smaller vacuum chamber. This did not work, and even worse than the previous one. We believe it was due to the large size of the vanes, since smaller size of vanes seems to work better with this experiment. You can see our attempts to perform this experiment. It is even worse than the previous one since it does not vibrate with the light. In conclusion, our three setups did not work properly. To make this radiometer work, we could use a better mechanical vacuum pump since if there are too many air molecules, this radiometer will not turn as I mentioned in the theory part. And we could use smaller size of vanes similar to the our second setup, since this system seems to work better with smaller vane sizes and smaller vacuum chamber. We could use even smaller vacuum chamber like a light bulb to make this system work in the future. And this was all. Thank you for listening.